Okay, number 5. What is the spring constant of a spring that stores 25 joules of elastic potential energy when compressed by 7.5 centimeters? So here's our equation for potential energy in a spring. Let's just quickly remind ourselves where this comes from. Remember, our equation for work done by a spring is 1/2 kx initial squared minus 1/2 kx final squared. The initial position of the spring is uncompressed, and then we're going to compress it by 7.5 centimeters. So that is our final location of the spring. And so initially it had a compression of 0. So the work done by the spring when the spring is compressed is negative. And remember, that means negative work is taking energy away from something. So the spring is doing negative work. It is taking energy away. And so that means the energy is now in the spring. So the potential energy of the spring has increased. So remember, work is negative of the change in potential. So negative of a negative gives me a positive. And now that is my equation for the amount of potential energy in a spring, where x is either the stretch or the compression as compared to the relaxed length of the spring. Right here it shows the relaxed length. That goes away. It's 0. Okay, so they tell me the compression. They tell me the amount of energy, 25 joules. Solve for the K constant. And when you do that, you get here 8,900 newtons per meter, or 89 newtons per centimeter. Now you have to be really careful here. This joules, a joule is the same as a Newton meter. So if I have to work in a distance of meters, so 7.5 centimeters is 0.075 meters. So when I do that math, there I get my answer in Newton meters. I get my answer in newtons per meter. That is our normal unit of K constant. But if you wanted to use the 7.5, just to show you, you can do it, but you have to be careful. You have to remember that a joule is a Newton meter. Okay, so if you do the math here, if you just plug in 7.5 and solve for K, you're going to get 0.8888. But that's Newton meters per centimeter squared, and that's not a unit of K. I can convert it, right? 1 meter is 100 centimeters, and when I do that, now these cancel, and I'm left with 88.88 newtons per centimeter. So just be careful. If you're going to use the 7.5, you have to convert this to centimeters here, or it's better, I think, just to keep this as a Newton meter and convert the centimeters to meters here.